Hey, welcome to week 4 already. Time seems to be flying. So today's topic is going to be software. But before we get on, I just wanted to just kind of look at the upcoming events and just stress this guy right here. Week 2 quiz is due, and I think I've got 21 completions, I believe it was, something of that nature. So if you haven't done it already, it will, I guess it'll shut off in 2 hours. So do it. If you haven't already, get it done. The other comment is I like there was a good participation on the discussion board this week, so that was great. And we'll touch on that as we go through the software aspects. And don't forget the week 3 assignment that's still open with its due date on the 12th. So assignments, I think it's usually I gave 3 weeks to do the assignments. Let me just flip back to professor mode. Okay. So just again, just quick overview of what we're doing and why we're doing it from the context of project definition and deliverables. We started with just, what is BIM, and you heard a taste of my flavor of BIM versus the other professors, and we're all generally in alignment. Talked heavily about client requirements and defining what are you BIMing and why are you BIMing it, and then we did a look at the BIM execution plan. So once you know what you're doing and why you're doing it and whether you're capable of doing it and where you're doing it, who your potential players are, you start to document. The documentation is what forms the premise of what you're doing throughout the life cycle of the project, how to address the owner's needs, how to address your deliverable needs, and how to share what software is being used, etc. When you do the BIM execution plan, you'll get into those, okay, so hold on a minute, what software? What are we modeling? Why are we modeling it? What's the reasoning from the BIM use, and then into the how. And software can be so convoluted. A lot of your responses in the discussion board, very impressive. A good spread of differentiation between building, civil, plant, collab, etc. And we'll talk into those weeds. And oftentimes it's not about, oftentimes it's just, what are you using? Am I using Revit? Am I using ArchiCAD? Am I using Civil 3D, etc.? Then it's not only what am I using, how do they all talk to each other? Or can they talk to each other? How do they share globally? Or can they? Is there a restriction? And then how do they meet BIM uses? So can I clash? Can I run it through a simulator? What type of quantities do I get? Is there an asset management link? What would a fabrication model look like from something sourced in one thing versus another? And depending on what BIM uses you're looking to harness, there's some specific, simple, am I visualizing? And if I'm visualizing, do materials carry through? And do they carry through the same way from Revit versus ArchiCAD versus EcoSim? And if I have multiple models and I'm visualizing something campus-wide, can I even do it? Am I using Max? Am I using Lumion? Am I using Lumen? Am I using something else? And you can just go on and on and on, all that from the BIM use of visualization. So imagine every possible BIM use and what that means. So today we're going to talk specifically on software. And I think, as learner, you can see where we're going, and I keep reiterating. So software, how we're authoring stuff, collaboration, how we're sharing stuff, and then deeper diving into BIM uses, bunch of deliverable requirements, making an overall technical solution, and then legal fun. That's kind of the next month and a half. So let's dive in. I was debating, based on the discussion, the good participation, what I was thinking of doing is kind of opening up for some dialogue first. But what I'll do is I'll go through the slides, because a lot of what was written on in the dialogues and in the matrices you guys pulled together were very complimentary of what I'm going to talk about. So maybe we'll do that. and then circle back and have any software dialogue. So let me go to presentation mode, and I will, as I'm talking, sometimes I get in the groove. I will keep an eye on the question panel and the raised or lowered hands. So I'll try to make sure I've got everybody covered here. Hold on, I got to dock the questions. So I'll just keep an eye on the webinar. Okay, so week 4, software. Specifically, need to debunk that very heavy and prevalent myth that you all, when you went back and I looked at the week 1 discussion, the BIM is Revit myth. Revit is an awesome tool. Revit does not encompass BIM. So what I'm looking to do here is talk about just to expose the possible softwares. A lot of these I've actually used in practice and had the challenge of making them all come together, which are case studies in week 11. We'll talk a bit about that. So if you remember the first week, I kind of had this slide of building civil plant. I want to kind of I'll focus on each one of those before spawning off into some other aspects. But building specifically, so this is, this is the myth. BIM is just for buildings, BIM is just for architects, BIM is equal to Revit. The first 3 myths that just irk me as a BIM professional and irk me when I'm having dialogue about information. With that said, there are many building-based BIM authoring tools, and I'm showing a bunch of them here. I would say the glue that ties them together are twofold. Is first of all, the IFC standard. So ISO 16, and I always forget the last 3 digits, but industry foundation classes, a door is a door, a wall is a wall, etc. So the data taxonomy of a building is rooted inside these tools. Now I list AutoCAD there, and right off the bat, you'll say, hold on, Brent, AutoCAD is a CAD platform, 2D CAD. I'll say yes, but they have their whole series of AutoCAD architecture, AutoCAD structural, MEP, AutoCAD electrical, and yeah, and those building ones, it's like kind of like Civil 3D and Plant 3D. They put a string of 3D tools woven into the DWG platform that are ISO or IFC compatible. So if you're using AutoCAD architecture and you press place wall, it's a wall. Now, the problem with AutoCAD is if you're using AutoCAD architecture, I can also place a line, offset it, and call it a wall, even though it's not an actual element of that is a wall. So there always is that quirk. But for the most part, when you look at that list of tools, my view is it's very hard to do unintelligent things with tools that are deeply rooted in the data taxonomy that enforces intelligence. The other thing you can do with these tools is specific analytical functions. So, I can't do daylight analysis with a civil terrain model, but I can do it with a building model because it recognizes transparency, translucency, opaqueness, and therefore you give it a light source, the infiltration of light into an enclosed space, right? Facilitated via the software. So you can have these analytical links. Structural is probably the one that's most common. Autodesk's Robot, Bentley STAAD, Bentley RAM, MathCAD, SAP, etc. So a lot of exchange formats that get you into those tools. Some of them are very technical, you need the CIS2 or whatever it is, but you can get there. The other data exchange piece is there's a whole host of, if you call it data visualization or data taxonomy readers that allow you to do the fundamental things like a room schedule, a door schedule, equipment lists, base quantities, and spec exchange, which I'll talk a bit about. I think it's in 2 weeks' time. That ability to link components to their specs and vice versa. So what I wanted to do with the buildings is, and I know oftentimes the audience are very Revit rooted. I think I said last week, I'm very excited. There's a lot of civil backgrounds in this course, but any piece of software, it's like you're painting. So I do have a bit of painting that background as well, back from my university days. And you look here, you got watercolor and you've got oil, and you have a resultant. They're both paintings, but they are fundamentally different in how they approach, yet they result in paintings. And you can see there's crispness versus not. For me, my use of watercolor would fail compared to I loved oils, acrylic, but more so oil. Others would say the flip side, the fusion of the watercolor you can't achieve with an oil, et cetera, et cetera. So it's, obviously everybody comes from a different background. It's very subjective at times. But the point of the slide is, if you imagine, if you're going to paint, you decide, I'm going to paint. I'm going to model a building. It's going to have components. They're going to follow the common taxonomy. No matter what anybody says to me, a wall is a wall and a door is a door. And I keep using those examples, so they're fundamental. And when you start playing with the fundamentals, these slides here I developed quite a while ago, actually, comparing Bentley's EcoSim and Autodesk's Revit. So 2 authoring tools, and looking at some of the base functionalities. So if I was just going to make a simple building, no matter what tool I'm using, and this would apply to ArchiCAD, Vectorworks, CATIA, it doesn't matter. You can have levels. So here I looked at, I'm setting my levels. The ability to generate walls. Very simple. You can select wall types. You can get into all the complexities about family building, parametric building. Is it a sandwich wall? Is it a generic wall? In my head, it's blah, 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 blah. You're going to model a wall, and you can make it as intelligent as you want to portray in 2D or to not. It is what it is. But there's so much, and even in IBI, the dialogue around wall types, it's unbelievable, but it goes on. And that's all good, because it is very important as an architect. You can do it. Place slabs, flood slabs, slabs by point, whatever the case is. Again, generic versus non-generic. If you remember when I showed that slide, BIM is nothing more than a component plus information. The very fundamental piece of information here is I am placing 3D geometry knowing it is a slab. I could then include, like the example on the right, it's a cast-in-place concrete slab on grade. That gives me a little more information about the slab. So if I was harnessing that, I can say, oh, it's a slab on grade. It would have less reinforcing, therefore a different cost index. So if I was giving that quantity to a cost estimator, that little bit of information will go a very long way versus, say, an elevated slab or a waffle slab or different other types of slabs. So keep that in mind. There's power to some of this information, but I always say when people are afraid of BIM, you're doing a slab, place a slab, you can always add more information if and when it's required throughout the temporal life cycle of the project. Always remember that. It can be a generic slab today. It can be a heavily detailed slab tomorrow. Place doors. The beauty about BIM is components like this are parametric, therefore meaning they will cut components they're supposed to cut. They will interact, frame, connect, etc. And they will contain both geometric plus non-geometric data to facilitate scheduling, for example. For an architect, the door schedule is this beast that we must do every single time. This saves so much time and money doing that. Same with windows, cut through, interact with the components, parametrically driven, connected, so they move with the components they're in. And I apologize for those with a civil background. I went in depth. This is my architectural hat on. Curtain walls, same concept. Really couldn't care less what application I'm using. It comes with the curtain wall tool, defining the parameters of the curtain wall, and I then place it in the system, in the model, and I have my full parametric capabilities. Roof tools, again, very common. And The beauty about stuff like this is I hated drawing roofs and working out roof slopes, especially when you have intersecting geometries. Here you're selecting that top level, assuming this is one level. You punch in your parameters, your overhangs, your slopes, all that good stuff. Is it a hip, a gambrel, mansard, whatever, and away it goes. It'll move with the components. It's all interconnected. It is, I don't want to make it sound simple, but it makes life quite simple when you're able to do this. Other tools like stairs, showing this because it is the commonality between building authorship tools. It's astounding when you look at stuff like this. And all of these things, different rail types built into the systems, different abilities to build components. As BIM coordinators, it often falls on us. Hey, look at the railing on the left and the railing on the right. Oh, you know what? That almost works, but I need one that does something different. So it comes back to us. Can you help us make the components and ensure that they're quality checked, especially if your teams are not very savvy in the development of content as opposed to just the placement of content? Creation of views, and then visualization of views. So you can have different hatch patterns, different colors associated with what you're generating. Revit by default takes that architectural penciled look. Bentley by default takes more of the CAD look when you're cutting your views. But again, you can swap it out and change how you portray it. It just doesn't matter. They're just view filters that allows you to portray your line work. These multiple words, so we're in English semantics, model cut views, extractions, dynamic views, sheet views, et cetera, et cetera, et cetera. You're basically cutting up a model to see pieces of it to portray. All the disciplines are there. The structural is actually quite impressive, and I would say with all of the vendors, because there isn't much in the architecture world. I hate saying it's more whimsical than it is whatever, but I'm able to architecturally dreaming up stuff, and then you're inventing content. In the structural world, I'm not inventing steel shapes. They come from the steel handbooks that are unique to each jurisdiction. So, North America, the Canadian steel sizes and the US steel sizes are the most prevalent, but both tools have, Indian, Singapore, the Australian, the UK sizes. The list of what's available for placement is amazing. They've done their homework. They've taken all those industry standard pieces and made them available for placement, columns, beams, etc. So the library is quite robust, and then built in those also is the weight of the steel, and then that equates to real powerful quantities that could come out of these models when steel is done correctly, plus a greater ability to have better fusion with fabricators when you're going steel direct to fabrication. Ductwork, you have a lot of, when ductwork is done properly with proper bend radiuses, proper placement of components, the airflow calculations and analytics are very seamless in both of these applications. And I've done a lot of configuration on the Bentley side, so there's a lot to it, but it does work really well. Cable trays are, for me, one of the biggest things on the electrical end that get forgotten. Because for me, they take up the most space. Often conduits can be field routed, wires certainly field routed, especially when they're buried within walls. There's a lot of heavy coordination when you have bundles of conduit. So, a 50 millimeter conduit, 2-inch conduit, you might not worry about it. But if I have 15 2-inch conduits having to go through the floor at the same location, all of a sudden I have a big hole that has to be coordinated. But cable trays with their turning radii and how they actually weave through your ceiling spaces are very critical, especially in plant-based projects. The other thing that's unique is the ability to move between platforms. So this is a technology that was released, I believe it was 2013, and it was through an agreement between Autodesk and Bentley. They said, look, we'll start sharing. And what Bentley did is they built in an ability to bring Revit families into their platform. So if you're familiar on the building side, Revit, they have the market share. Autodesk's marketing engine is quite impressive. And for a decade and a half, they've spewed out BIM, Revit, Architects, Revit, over and over. So you think BIM, you think Revit, and away you go. Bentley knows this, but they have a lot of major projects, especially transit-based projects, that look to harness building information along with its linear information. So they have this robust tool in EcoSim, but it may not have the component background that Revit has. So they built this RFA interpreter. Basically, you point at the RFA file, you map a couple of Revit parameters that are built in the family, and it allows you to place the component as a Bentley object. It was, for me, a bit of a game changer because it just opened up that library that existed. I also did a research project with the University of Toronto. Goodness, this is probably 5 years ago now too, where we wanted to use the IFC file as an interactive medium between Revit and EcoSim. So the proof of concept was to see how interoperable you can be. And here it was, you have something in Revit, we add a comment to it, we bring that same IFC file into EcoSim and interpret the comment, add more to it, and move back and forth. The practical nature of it was really the question of, can the research prove that you can traverse platforms successfully? And, it proved to an extent, yes. And I say that because, as with all pieces of software, this stuff grows. You get new versions every year, new either pieces of data or pieces of functionality that get added on one side and are not yet interoperable on the other side. So IFC is a very powerful tool because it is an open BIM technology whose premise is you bring everything to the fundamental interoperable data taxonomy for geometry and information. And that taxonomy is guaranteed to be able to move into different software vendors. The challenge is when I go from Revit, EcoSim, ArchiCAD, etc., to IFC, I'm by default saying, I hate saying dumbing down, but I'm lowering the extent of the geometry and the information to be compatible with the taxonomy of the IFC file. And then once I'm compatible, I'm open everywhere. So this research project looked at it precisely that. Take a simple building at the lowest common denominator of taxonomy, and then allow fusion back and forth between platforms, adding information to the data definition of the IFC file itself, using a quick little widget to visualize it in each application. So it was a fun project. It's one of those research projects that, if you have opportunities in North America, you have the ability to work with universities, you get government grants, look at how information can move back and forth. This one touching on the capturing of commenting to and from each platform. And of course, the validation was going into Solibri, which is an IFC viewer, and having all that information registered as an IFC element or a piece of information. So that's the building side. I just, I didn't want to dwell on building-based software because I think, you're going to get a lot of exposure to that on the tools and processes. In the IBI world, it's interesting. What I wanted to note, though, going from theory into practice. So, I teach BIM, I profess it. BIM is interoperable. Any one of these applications can work. In my real world life, in my IBI world, I'm not going to procure you a license for every single one of these applications because they all could work. So IBI has standardized on Revit. It was what they did, obviously before I was there. And the trick now is, as we explore each project, if I declare Revit is our building authoring tool standard, then I need to analyze, okay, do I have enough software licenses, so enough network licenses to accommodate my installations? So we do license monitoring. I make sure I've got standards, best practices, content, you name it, it's all there. Then when I get projects, and we do have some, for example, the Toronto Transit Commission requires requires EcoSim. So with those EcoSim projects, then it's a thing of beauty, because now it's new license procurement for specific areas of our firm, knowing that the ability to work on these projects are much narrower because all the training has happened with Revit software. With that said, if you know Revit well, it's not rocket science to open up EcoSim and explore it and understand it. So we're balancing that right now and looking at how we're going to deliver the EcoSim required projects, knowing that our user base is Revit. Back at CH2M Hill, it was completely flipped. EcoSim was the standard, but more and more we were having to deliver to clients that were Revit based. And interestingly, we had 1 or 2 ArchiCAD based clients in North America. So there was a lot of question on how to have our digital deliverables traverse the platforms in order to meet delivery, or to redefine how we're delivering by embracing different software. From a BIM coordinator's perspective, you have to take the approach that it just doesn't matter what software you use, especially here in school. And it's part of this program. If you're modeling a building, any of those can work, period. You just have to have that fundamental understanding. And I think one of the questions in the next quiz is going to be precisely which one of these tools can you use to model a building. I'll either list them and it'll be all of the above, or I'll list them and a whole bunch of them will apply. And that's a very critical thing. Building modeling, any of those. And then you'll notice in the workflows course and the tools course, obviously Algonquin College can't afford buying licenses for all of those. So they standardize on, I think, getting on Revit and whatever other ones that have been granted student licenses or free licenses for students. That's a monetary fundamental, makes sense. But processes and project definition, any one of these can work. As a deliverable, any one of these can work. I think I've stressed that enough. So just please take note of that. Then on the next side is our civil tools. And from a civil perspective, I think the most critical message is if you're in a firm and they're trying to do civil engineering, terrain modeling, modeling of the site, and they're trying to jam it all into any of these building tools, as a BIM coordinator, the first comment you can say is, my goodness, stop. These are our civil tools. And I say this so forcefully because I have seen architects trying to push civil engineers to use Revit because of the big myth of everything is in one big monster model. So if my building is in Revit, doesn't that mean my site has to be in Revit? And all my roads and my sewers and my utilities and my data networks? And the answer is just no, 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 and no. Information must be authored in the appropriate BIM authoring tool. As BIM coordinators, if you come from a civil side, you may see those and say, good, I get those. If you come from a building side, you may have heard of these, you may have never heard of these, and that's okay. BIM coordinators do not have to be software experts in everything. When I came into the role, so I have an architectural background, but I never knew Revit. I knew AutoCAD. I knew, if any of you have been around as long as me, you may remember Architectural Desktop. So it was the precursor to the AutoCAD architecture products. So I came through the DWG realm, but I got a job at CH2M Hill, and the first thing they said was, we're a Bentley firm. And I said, what's that? Well, what's MicroStation? I didn't know any of that stuff, but I knew AutoCAD. So it was, okay, now I can compare my 2D CAD, and I knew Autodesk Architectural, so I was able to get into the Bentley architectural world. Civil, same concept. So focusing specifically on the civil tools, again, any one of these can work. A bit of a challenge here, though. Unlike building, where the IFC file is a fundamental lowest common denominator taxonomy, there really isn't a similar thing for Civil. And what I mean is, if I'm in Civil 3D by AutoCAD, Autodesk AutoCAD Civil 3D, and I want to take the intelligence plus the geometry and place it into Bentley's OpenRoads, it doesn't work well. I think it's slowly getting better, and they know they need to be interoperable, but it just is not happening yet. Same with the Esri GIS end. So there could be MapInfo, which I don't have listed, ArcGIS. They can pull in fundamental data layers, but still not entire digital terrain models. So there's a little bit in the industry, there's a little bit of an interoperability issue here. The other thing to note, if I'm in the world of Bentley, everything is one file format. So I can have my building and my civil. At the end of the day, it's all the DGN file, and they talk. At least they can link to each other. If I'm in the Autodesk world, my Civil 3D is a DWG, my Revit is an RVT, and wouldn't you know, I cannot reference my building into my civil. So you got to jump through hoops. Not challenging hoops, but you need a workflow. And it'll come to the BIM coordinator. Oh my God, I can't link in my building. I can't do my civil. I can't deliver my project. Your BIM technology just doesn't work. And I've heard that all my career. You take it in, you say, yep, it works. This is what you got to do. You might have to show them. So, you know, if you're familiar with the push and pull of coordinates, I could have my site in Civil 3D. I publish the coordinates of my site. I go into Revit. I pull those coordinates in, define my location, and then I share my coordinates, and away I go. And it's shared across all the Revit models, and then there's this push and pull. At least the coordinates are shared, and you can make things work. The beauty of the Civil tools is that the data exchange is very specific on cut fill analysis, quantities of linear layers, terrain modeling from digital terrain files, triangulation, super elevation, etc., and exchange with specification information. And it's all very well coerced with the linear environment. You can't really do any, okay, quantities obviously, but you can't really quantify the linear in the world of Revit or in the world of the building tools. So that's why I stress this, because if something's trying to be placed in the wrong industry-specific application, you just will not achieve the desired BIM use. When you look at the analytical components, I was on the Panama Canal widening project, and they were talking about subsurface manipulation and quantification of really the salt layers of the land between the north and south portions of the canal, Atlantic to Pacific. And it was the salt conditions that had a negative ramification on the actual dredging and location of the lock systems. So a very specific item that I had to address, and it was all based on the linear terrain modeling, surface X-raying, and GIS data layers all brought together, analyzed to help lay the alignment of the locks relative to the bodies of water. So it was very unique. I mean, it's just not a Revit thing, just to be blunt, right? It's not a building thing. So this is some of the, as I was talking through the application, so just talking a bit here of Civil 3D. If you've never used Civil 3D, this is an example of it. Pipe networks, alignments, roads, terrains, etc. One of the things, so for me being an architect, I never use this for design, but I definitely interact with people that use this. The concept of Civil 3D is the sharing of this data shortcut project, or a DSP. And if you've used them, great. If you haven't, just take note. Different from Revit. Revit is a central model. So we're all playing in one big sandbox, changing things, manipulating things, and seeing it live. If you touch a door, it's locked from me until you sync the door and I see what you did. In the Civil realm, it's not a big central model. So there's multiple DWG files for AutoCAD Civil 3D. The trick, though, is they use these data shortcut projects so we're not all making the same thing. And when I demonstrate this internally, I always say, okay, look, I'm going to make a pipe network, and it's called pipe network number 1. Now, if you make a pipe network, well, yours is not going to be called pipe network 1 because I called mine 1. So basically, I register mine with the Data Shortcut project. So when you open up Civil 3D, access the DSP, you'll see pipe network 1 is already made. You can add to my pipe network by adding more components to it, or you can create a new network, pipe network 2. In the practical realm, it could be I'm modeling gravity sewers, and you might be modeling water supply. So you start that, and I start the sewer. And then in the same file, or I might open a different file, make an add-on to the sewer pipe, and then you'll make an add-on to my water pipe, whatever the case is. But we're harnessing the same defined data and not duplicating it across the project. The chaos that avoids is simple. Think of quantities. If I wanted to quantify my pipe networks, I don't want 2 storm sewers that are identical scattered across a campus or a major project site because we both name things incorrectly. So if I'm pipe network 1 and you're pipe network 2, the components are assigned accordingly. If we have 2 different systems named the same because we're not connected via the data, we have chaos, quantities don't work, other elements won't work, and if we're trying to identify systems for clashes, that can't work, and it would just be chaotic. So very fundamental, and I stress this because when we get to the collaboration next week, how do you share this? Think about that as we're going through these projects. I kind of glossed over buildings, but think about sharing a Revit Central model. Think about sharing the EcoSim DGN files. Think about sharing this Data Shortcut project, and not just within your office. Think about multiple offices and multiple geographies. So Civil 3D allows, the comment from Shrey, Civil 3D allows the team to work on the same file at the same time similar to Revit. Yes, no, that is understood. So I don't want to misinform you from that perspective. Yeah, Civil 3D does allow for multiple people in the same, but in an industry practice, I would say that, you know, in the years at CH and in IBI, the lesser, so in the DWG world as well as the DGN world, because in MicroStation, 2 people can work on the same file as well. It seems that the technology is growing to allow that more and more, but fundamentally, Revit started with the big bucket of everybody in the same spot. The file-based systems started file-based and started to interweave them to allow this. But in that same vein, so imagine that we can now all work on, or more than one people in a DWG or a DGN, DGN being Bentley-based, DWG AutoCAD-based. How do you share? And it's the sharing that becomes, I think, the biggest complexity of a BIM file. And for me, it's been the struggle that I've had in the Revit world from day one. And I see that in IBI today. Revit's the easiest to share when we're localized in our single office and I have multiple users over the network. Great. Now, all of a sudden, well, we're too busy. In IBI, just a sidestep here for a moment, our Toronto office is almost maxed out. Our Vancouver office is maxed out. They're 2 of our largest offices. So we have these Revit projects, and they say, well, great, well, can't somebody help from Seattle? Can't somebody help from Calgary, Edmonton, you name it? We have 60 offices across the globe. Every single time we start a project and then say, can't I add somebody else? And that somebody else is now elsewhere, completely changes the collaboration. So we'll talk, and I think next week we'll have, this is the specific dialogue on what mechanisms are there to help us to share. And then as a BIM coordinator, when does technology go too far? So, I've struggled on the Revit end. You can make a Revit model gets up to 1 gigabyte and everybody's feeding it. When is that right? When is enough and you start to split these models? CH2 of Hill, we were very rigorous on splitting by streams of data. So in the building, we would split by supply duct versus return duct. And this was all in the DGN world. So supply versus return. Hospital could be split by a service stream. So air versus so oxygen versus cleaning air versus water versus medicinal components versus chemical. Treatment plants, very similar. Site utility, very similar. When's the right way and how to do it? You have to think about that as we go through a bunch of these systems here. But no, thanks for that. Open roads, similar concept. It's a DGN file format. As I said, definitely you can, the DGN file is expanding to allow for multiple access, but was rooted in what's called file-based BIM, if you will. The DTM backbone is very similar to the backbone that's exposed via Civil 3D. Data is shared via file referencing, so there is actually no DSP in the world of Bentley. Bentley, if you've played with their software, it's very interesting, and I've seen it on the building side and the civil side. A file reference or a linkage or an X, so whatever semantic term you use, allows you to reference and then subsequently interact with data. And I've noticed that there's limitations on some of the Autodesk tools and some of the other tools where linkages are just assemblies, if you will. You can't really interrogate unless you either have to go through some specific workflows or you just, have issues to do it. These Revit site tools, again, and actually, if you look at the difference here, the intensity of Civil 3D, I think the images kind of speak 1,000 words here. Inroads, even though this is a bit of an older screen grab. I like describing site tools in Revit. I hate saying as like a sites cartoon, but fundamentally it's not a civil engineering tool. With that said, with every single version of Revit, you get more and more complexity or more and more capability to place civil-based items. The ideal situation, and I noticed in 2019, it's starting to hint at this, is to have more of a seamless, hey, if you want to see your land XML or you want to see a Civil 3D file, to actually have more of a live connection. And that's what Autodesk is working on. So, maybe in a couple of years, I completely flip the portrayal of this to be, if I'm in Revit, I'm having now a seamless view into the world of civil. As an architect, I'm actually accountable to have an architectural site plan. And in the industry, oftentimes the architect just goes off, does something like this, shows an access road, shows all the parking spots, and it's specifically for parking that I need to actually show this, without really giving true thought on drainage, utility networks, and things of that nature, site sloping, parking lot sloping, all of that's usually given to a site civil engineer. But if there was a better seamless nature as a BIM coordinator to actually facilitate the data exchange, as an architect, I should not be duplicating data that I know is being owned by a site civil engineer. And I think maybe, as a takeaway of this, if you envision Revit really as dabbling into the site civil world, so it's really the civil components as they relate to the vertical infrastructure that's being modeled. In addition, then you have the question of landscaping. And landscape BIM is quite a challenge. And let me just go through, oh, that was my next slide. Awesome. Okay, I forgot. Big challenge with landscape. I described landscape as being in the netherworld of BIM. So if you go out and ask the vendors, there's building, civil, and plant, and you say landscape. Well, it's civil. But what about when it's around buildings? Oh, maybe it's buildings. And you look at them and you say, well, what does that mean? So the examples I have here, and they're not wholehearted, but I've seen Civil 3D used as landscaping. So they basically use the engine for undulating landscape that goes across a non-vertical terrain, if you will. So roads, highways, rails, etc. Bentley's equivalent in open roads would be similar to that. I've seen Revit used to some varying degrees of success when doing what I call hardscape or urbanscaping, and that would be landscaping around physical built forms. So there's going to be a model that's a concrete slab that represents an elevated planter, or something on an urban level, or just basically the building fabric extended however many meters outside of the model to encompass the landscape. And we've been trying to make components that fit with that. And, you know, for the most part, we have successes in some of our offices where we have that work well. LandFX is a pretty interesting one that some of our offices use, and we've seen it used for us on transit projects, where there are buildings, there's going to be an alignment, either a roadway, a railway, or a busway, or something of that nature, and we're responsible for the landscaping fabric along the entire kilometer or mileage of project. So here, LandFX basically sits on top of the DWG engine. So you can take a Civil 3D alignment, bring it into, or harness the LandFX tools and use it to generate your content. And it gives you landscape lists, and the components have proper caliper definitions that allow you to go directly into potential procurement. And it also has proper bulb and root sizes to allow for potential clash detecting with buried content like buried utilities. Other ones you might have heard of is Keyscape makes LandCAD, which we kind of reviewed. It kind of does okay. You know, I don't want to diminish any other ones. And there was one more in my head that escaped me now. But, you know, what I like about this is and the thing about LandCAD is it tries to be IFC compatible. So it has an export engine that goes straight into the IFC taxonomy. So, you know, for being in the netherworld, there's a lot of effort being put in place to try to connect the landscape professionals to one of the streams of information, whether it's building or civil. ArcGIS. So IBI, we definitely have a heavy GIS presence as well. So if you're not familiar with GIS, it's Geographic Information System is what it stands for. And I love describing it as just a way to visualize data. And you're visualizing various layers of data focused mostly in the horizontal realm. So examples could be existing utilities, proposed developments, proposed or existing site parceling and site divisions, road networks, rail networks, communication lines, electrical lines, and then you could get into demographics, expensive land versus inexpensive, proximity data analytics, so proximity to transit, proximity to recreation centers, etc. And all this information can be analyzed and used to inform you potentially of development hotspots, maybe where to locate an office, maybe where to optimally place a transit alignment, stuff of that nature. Very powerful, and I would say really no limits to what could be done in the world of GIS. In my past, when I worked on the London Olympics, the GIS was an actual formal deliverable to the government. So they wanted a portal that allowed the public to understand what was happening at Stratford Park, from remediation straight through to final games, holding of the Olympic Games. And remediation included, where did we find toxic land? Where did we have to clean the ground, remediate the land, and get it prepped for development? They were looking at what houses were taken over, or how much residential versus industrial versus commercial had to be appropriated in order to facilitate the games, location of recycling and how much content was recycled from various sites in order to facilitate IOC requirements. And then, of course, the development, the new transit, the new waterways, etc. So it was quite an involved process to ensure that we were communicating publicly what was being designed and constructed within the realm of the project. So very powerful, and we try to infuse it quite a bit in the IBI world. So in our world, if you look, these are the applications we harness today. Now, notice I didn't jump very deeply on the Bentley side, but just to make you aware, I highlighted their inroads in Geopack, and I did not highlight MX. If you've heard of MX, MX is, well, let me step back. Bentley was very disjointed in the world of civil. So for a decade of my career at CH2M, we had pockets that used inroads, some that used Geopack, some that used MX. MX was more UAE and eastward towards Asia. Inroads, the bulk of the DOTs in the States, Geopack, some other departments of transportation. Canada was a mixed bag, and then Civil 3D scattered all over the place. In IBI, Geopack and inroads in our operations are really just a couple of the departments of transportation and some local work in Ontario. Bentley has finally decided that having 3 tools that do predominantly the same thing is a little nuts. So they've combined it all into the application called Open Roads. So in theory, they took the best of each of the 3, merged it into one. It seems like it's been a decades-long process, but they finally have a formal rollout of that. We are experiencing projects where clients are now requiring Open Roads to be used for design and delivery. So that's exciting that that's actually progressed. I didn't mention on here, there's a pretty well-known application if you're from Australia called 12D. And that is their most common civil authoring tool that's prescribed by many agencies in Australia. So where there isn't a prescription, you're free to use what you use. So in that breath, in the world of IBI, on buildings, Revit is the most common. For civil, even though we have a heavy use of inroads and Geopack in certain jurisdictions, Civil 3D is the most common globally. So I'm in the process of trying to figure out, again, licensing, training, content, standards, global deployment, the ability for everyone to work together when they need to. As previously mentioned, when you're working on trying to now work in one file versus multiple files, harnessing cloud-based sharing versus server-based sharing, which we'll talk about next week. And then in the world of GIS, we've got GIS practitioners that are literally scattered across the globe. There's about 40 of them. No one office has more than 3. So there it's using heavily ArcGIS online as well as installed desktop applications, and when they're working together, just how to share these mass data sets and mass collections of information, and whether it's sharing it just to augment and adapt or to actually do something with for other projects. Again, the takeaway, we talked buildings and civil, and here it's okay, take a pause for a moment. Remember, this course is project definition and deliverables. I think the first day I said, what are you BIMing and why are you BIMing it? What are you BIMing will heavily dictate what you're doing here. If you hear we're doing a road and you hear we're using Revit, I don't care who the audience is, that's a flag. Why are we attempting to model a road in Revit? That would be my first question. I want to see how we do that, because as of right now, we don't. There is no delivery of roads in Revit. You might try to portray it for whatever reason, but it doesn't happen. So things like that. Or I'm trying to model a house using ArcGIS. Just no. I don't even know how else to say that. It just doesn't happen. Then there's plant tools. And I stress this, and in week 5, the assignments, one of the, just as a precursor to that, I've got project examples. One is more building focused, one is more civil focused, one is more plant focused. What I've noticed in my career is a lot of the BIM coordinators that go through training come out clueless about plants, just clueless. And when I look at these plant tools, one thing that excited me in the matrix is a lot of you identified, okay, whether you looked ahead at some of the presentation material or you have actual practical familiarity, there are plant-specific tools. And we talked about this, I alluded to this in the first day. There's an entire ISO standard that governs plants. It's 15926. When I talk to architects, never heard of it. When I talk to civil folk, never heard of it. It is so fundamentally important. And when you leave Algonquin, you may or may not go to a firm that does buildings. And it was interesting that the way my career took shape was finding CH2 of Hill, who's now Jacobs, and being put on that first project and said, Brent, here's the P&ID. And I just looked at them and I said, I graduated architecture school 4 months ago. Nobody ever told me what a P&ID was, a process and instrumentation diagram. The Bible of how a process plant comes together. And that information is asset rich and directly tied to 3D models. If any of you are Revit users, I put Revit in there reluctantly 4 years ago when I made this slide. Now it's actually a little more valid because Revit 2018, I believe it is, actually has an AutoCAD P&ID linkage tool. Very, very exciting. It's about time. For Autodesk's history, it's always been, let's acquire things, let's let them live, but don't ask us to make them talk. They're finally starting to bridge their applications. So that's a very exciting thing. Now, of course, I challenge Autodesk. If you want me to do stuff in Revit, why did you give me Plant 3D? But I digress. So you look at those list of applications. Why are they important? So look at the data exchange. I already said P&ID to model. So right there, I have a pipeline. Pipeline number one, it's going to have 5 valves, maybe a tank, maybe a pressure indicator, maybe empty into a filter, and maybe a chemical injector. All good. I'll show that simple line, little markings for all that stuff. Well, the P&ID to piping model is going to tell me, hey, looking at your P&ID, you said it's going to have 5 valves. Looking at your model, you have only 4. You're missing a valve or your P&ID is wrong. I can address it. Immediate quality checking between my P&ID and the model. And the other thing for you to note, oftentimes in the world of plants, the BIM use of owner's asset management is almost guaranteed to be at play. And at the bare minimum, it's taking that P&ID that eventually becomes the schematic of the operation screen. So having this connectivity, what's going to be in the face of the operator, what's in the face of the designer today, directly connected to the model of the place, the physical model of those components. The bill of material quantities, like we're talking robust bills of material that go straight to procurement. And CH2M is in a lot of DBO projects, so design, build, and operate. When you're in an entity like that, to mass procure across multiple projects, you can save millions. And you can only do that if your BOM information coming from the P&IDs in the model are correct, numbers are accurate, and there's just no duplication. You save money. Data sheets, tell me about the valve. So if you come from the world of Revit, you click on a component, you can look at the properties. Or you come from the world of plant, you click on anything and it has properties. And it's explicit to what's being placed. And I'll show you that in a moment. And then the exchange and specs is this fundamental backbone. In the world of buildings, I dream. Let me have my model, scan my model, do a fundamental first pass of my technical specs. In the world of plant, specs come first, laying the premise. And I think I described in week 1, copper can only go from a small size to a large size. So if it's, I don't know, 1/4 inch up to, I don't know, 3 inch. If I want to come in and make a 10-inch copper pipe or a 50-inch copper pipe, system's going to say no. In the same breath, I will never make a 1/4 inch reinforced concrete pipe. It will never, ever happen. It's just nuts. So that happens. The other thing, pipe stress and hydraulic flows. So hydraulic, if you've never heard of that term, My work with water treatment plants, basically water has to go from the lake through the treatment to a water tower to your tap, okay? Dependent on hydraulics. So I'm either going to pump the water everywhere it's got to go using a lot of energy, or I'm going to strategically pump and let gravity-based hydraulics do the rest of the work. Water is thrown up into a water tower because then hydraulics can let it flow with a high pressure into the distribution network to your homes. When we're pulling water in from the lake, we're very deep in a lake. You might be pumping it a couple times, and once you pump it high enough into your treatment plant, it'll naturally flow through the system to get put into distribution. So, you know, there's that there. From a BIM coordinator perspective, you'll hear that and say, how am I supposed to know that? Like, you're not. You're not supposed to know that. But you might get exposed to that. You're going to be sitting there looking at a process engineer, listening to him talk about all of this, and you're going to say, okay, so what do you need the tool to do? And then he'll stop. And then you might say, I don't know. But the critical thing will be, you'll want the information to talk to each other. Pipe stress. How do I know if my pipe's going to break? Well, if I'm in Revit, I won't. But if I'm in a plant tool and it knows the pipe is going to have maybe a corrosive material, maybe a pressurized material flowing at a velocity of something with so many turns along the way, it's going to tell you, hold on, the way you've designed the pipe, you're going to have a catastrophic break in this location. So you need a pipe support, a brace, or it just won't work. You got to redesign. And it'll give you all that information. Very, very powerful stuff. So some of the tools that I've been exposed to, plant space piping. Critical thing about all these I'm about to show is they're spec driven. And I remember when I listened to people complain to me in the past, the complaints go something like this. In the world of 2D, I would draw a line. In the world of 3D, it asks me all this information. You're slowing me down. And the response will be, no, I'm forcing you to think. In the world of 2D, you should have had all these answers. In the world of BIM, you need to have all these answers. And the reason for that is in the plant world, you don't model rubbish. You shouldn't do that in the building world either, but you can't in this world. If I'm modeling this pipe, in this example I'm showing here, RW is raw water. I need to know I'm modeling the raw water pipe, the pipe that's going from the lake to the plant. I need to know the material. And if it's flanged ductile iron, it's going to have a limit on what I can actually model because of limits of gasket sizes, limits of flange sizes, the requirements to bolt your flanges together, and the limitations of pipe spools. And remember that in the piping world, anything we model is dependent on its ability to get to site. So if I model a 50-meter long pipe, that means I need a 50-meter long modes of transportation. So a 50-meter long rail cart, I don't know, I guess a pipe can span multiple carts. What if it has to be tractor bed driven? You have a limitation there. So if there's no rail network that goes straight to your site, a 50-meter long pipe is probably a very bad idea. Hence, you flange it and you think about spooling lengths. And again, from your perspective as a BIM coordinator, the answer is, I have no clue, but somebody does. Somebody outlines every single piece of information that's put into this spec. Maybe it's the vendor. Maybe it's the AWWA standard. So the piping standards in whatever jurisdiction you're working, or maybe it's your piping engineer. So here's a close-up of some of that information. And the other stuff it does ensure is it protects against the type of fittings. So this one here, it's what we have called a long elbow. That means it's not going to be an immediate 90 degrees. That means I need room to have the elbow. And if my pipe is super large in diameter, I need a lot of room to turn it. Therefore, as a designer, I might not want to turn it. But as a BIM coordinator, I want to make sure that if there's a limitation based on the spec, that the people have that at their disposal. This is a spec that I've written, and you know, a lot of them look very similar to this. And again, I'm an architect. I have no clue what's right or wrong, but I can read the standard and impose it on here. Or I did a lot of work with the piping people. So here, for example, if you look, PVC, this AH. So somebody declared that ammonium hydroxide can only go through PVC and not through another pipe. And its minimum size is 0.5. This was an Imperial project, so 0.5 of an inch. Couldn't go down to 0.125, which is an eighth inch. So a lot of these decisions were made. So then when the modeler gets this, there's no choice. I'm not going smaller than half inch. This restricts it. I would love as an architect to have this capability, because if you notice in Revit, by picking on Revit, but it can be any building tool, somebody can make a door family and the door can be an inch wide or something ridiculously wrong. So you can do that stuff. Whereas if something was meant to be a door, I would love a spec to say, sorry, minimum door width is 600 millimeters if it's in a closet. Is it in a closet? And then you say, no, it's going to be in a hallway. Minimum door width is now 900 millimeters. Is that where you intend to put it? No, it's a fire separation. Boom, minimum door width is now 1050. And I would love for a spec to fundamentally drive the building ops the way we do it here in the plant world. And that's something, if you have opportunities for research projects or to actually build applications that can impose on the building side, that would be exciting. AutoPlant is another tool out there. This is a unique one. It's Bentley tool built for AutoCAD. And the history behind that is AutoCAD's piping department really sucked for Autodesks. They didn't have anything 10 years ago. So Bentley said, we'll get you. We'll build a tool that harnesses our robust specs that we had in the world of plant space, and we'll put it on top of the DWG format. All of a sudden, all these Autodesk customers were buying AutoCAD from Autodesk, and then this piping application from Bentley. And very similar, it interacts with a lot of the Bentley-based applications, but a similar concept. So here you see in AutoCAD, I'm able to call up some piping specifics, make my selections based on backbone specs. Specs look very similar across both, because again, they're all governed by the ISO 15926 standard, and then place it in. AutoCAD shaped up and said, we're losing a bit of our market share. So out came Plant 3D. Plant 3D said, hey, you AutoPlant users, stop going to the Bentley world, stay with the Autodesk world, and we'll give you this. Similar concept. And this is quite a good tool. Their spec catalogs are quite robust. They have a lot of the components that you need. It's very comparable and compatible to the others. Again, ISO 15926 compatible. So you're selecting items, you have your bill of materials. This here in the top left, I wanted to just talk about this for a moment. In the piping world, the generation of plant-based isometrics are very robust. So as a deliverable, instead of just schematics like you see in the bottom right, or typical plans and sections, you take your stream and you deliver it by an isometric. So this goes to, am I working on one file or multiple files? Do they all come together? I believe Plant 3D, like Civil 3D, is dabbling in multiple people in a single DWG. But the critical nature here is the division of flow streams. So flows that can be isolated with the proper bill of materials, proper isometric. That top left is handed to a fabricator, and they fabricate. Pipe spools are generated, delivered to site, and away you go. It's very powerful. If you've heard of Intergraph, this is Intergraph's formerly their PDS tool, so plant design software that grew into Smart Plant 3D. I've done work with them. Similar concepts, spec-driven backbone. This is the old interface of the PDS. Again, you're selecting components and you're placing. Sorry, I'll stay here for a moment. One of the biggest challenges with some of these tools, and I'm not sure I mentioned it is the existence of a SQL database backbone. And I want to stress that for all of these plant tools. So Plant 3D, Intergraph, Smart Plant 3D, PlantSpace, AutoPlant, and also OpenPlant, which I'll talk about next, all have a SQL Server, SQL database backbone. When I worked at CH Twilliam Hill, that was a struggle because a SQL Server had to be in a single office and the need to collaborate was hindered. When we get to that week 5 assignment, remember this dialogue, hopefully parts of it. Ask me questions. When you have any type of plant software, if plant is being done in multiple offices, it has to be accommodated. So luckily, in our world today, and I wish I was at CH when this was in existence, Microsoft Azure allows for cloud-based SQL servers. Game changer in the world of plant modeling. So in the assignments, when the next one comes, where I identify plant is being used, it'll prompt you to potentially select the appropriate software, and it'll prompt you to decide, well, how are we going to share this stuff? And as a BIM coordinator, you can look and say, I don't care if it's OpenPlant, Smart Plant, or let me rephrase that. Maybe I don't care. Maybe. Depends on the particular of the project. But tell me where it's being used. So one of my historical examples, Smart Plant was on the project. Very database heavy, required a local SQL server. There was no Azure capability. Or you might have a client that says, I know you can put it in the cloud, but this is secured information. It's got to be on-premise in a single location that we approve. So even though there's cloud, you might not be allowed to use the cloud. So my first question was, who's doing the piping and who's doing the instrumentation diagram? And please tell me it's in one location. And I lucked out on a lot of projects where it was, yep, it's one location. We did the setup and we worked out how to collaborate. The struggle is when it's in multiple locations and you're tied to wide area network sharing, which we'll talk about next week. Just continuing on the plant here, Bentley's OpenPlant, great application, very similar to the rest. And if you notice a common theme with all of these, you grab components, you place them, you select your spec limits your geometric particulars, limits the type of fittings, and allows you to place, okay? The thing with OpenPlant, and this is something that Bentley does often, like with EcoSim, where they've said, you know what, if there's a real good Revit component, let you place the Revit family. Same thing here. They've said, okay, you know what, if you've got pipe specs from some of these other systems, the old PDS, PlantSpace, AutoPlant, now I think they also include Plant 3D, their view is grab a spec from anywhere and we'll let you place it. So you don't have to be, all your stuff doesn't have to be in Bentley to harness Bentley. So as a software vendor, they seem to be doing that the most. So just know that. Autodesk, not so much, but they seem to be getting a little better in recent years. So that's been my experience. So that's the plant world. And again, in the IBI world, so just so you're aware, if my BIM hat is on, anything goes. When my business hat is on, yeah, they're all good, but you're not going to go and grab one of every one of these. So where we have plant work, we try to standardize on Plant 3D because, again, it's the most common platform for all of our work. Now, I alluded to the Revit piece. When I started doing plants, Revit was horrible for any piping work. You just wouldn't do it. Now the piping, the families have gotten a lot more robust. They have a lot more standardized components in there. And now they finally have a P&ID linkage. So that's a big thing. PDMS is a very popular system since we're so in the Middle East. To be honest, I can't think of one example in North America where I had to interact with it, but many when I was working in Dubai and Abu Dhabi. So again, I wouldn't even bother showing you the tool. It's exactly the same thing, right? You're selecting components, you have backbone specs, etc. So that's kind of, if you will, the ecosystem of BIM authoring tools. And it doesn't represent everything. That's why I should have put other in every single one of these. Some of you had some pretty interesting ones in your matrices, which is awesome. And more come out. The challenge and what I have found, let's say I want to implement BIM Track, BIM One, elements of Solibri Checker, FieldWire, there's all these cool things that are there. Oftentimes we struggle because either they don't have the global breadth or a backing to use, or a client hasn't heard of it. And then, it just doesn't happen. I had a similar example at CH2M Hill. We had a tool called M-Pipe when I started. And I said, all right, well, what is it? Had some fundamental specs. It was actually a custom tool that they made back in the 90s. One time, a couple clients said, I don't want your custom crap. I want one of these standard ones. So kind of migrated away from the custom and adopted one. The other one I didn't touch was CADWorks. And I had quite a bit of work with CADWorks in my previous life as well. It's an Intergraph tool, again, uniquely designed to sit on top of AutoCAD. So AutoCAD got attacked a lot because it's the most common 2D application. It's everywhere. Bentley made AutoPlants to go on AutoCAD. Intergraph made CADWorks to go on AutoCAD. And then Autodesk finally said, oh boy, we better make one. So they made their own Plant 3D. But CADWorks is a pretty slick application too. Identical, pipe specs, backbone, P&ID connection, same story. So with that, if you recall, before I jump, BIM execution plan, what's your software? Usually you list all your disciplines, okay? And just as a general rule of thumb, because I know with the software matrix, when you think of some of these, when you're doing your BIM execution plan, architectural, structural, mechanical, electrical, plumbing, most likely those 5 will be harnessing a buildings tool. When I say civil, I don't think it does it justice, but civil, you could have civil site, civil transportation, civil utilities, civil site electrical, et cetera, et cetera, et cetera. Okay? You might have different tools. I'm only touching on some in the civil. You can have open roads. There's now open rail. So again, Bentley's concept is the same backbone, but they add rail network tools as opposed to road network tools. The utilities can be both potentially in the roads application funneled with a bit of the plant application. So you might have to ask a bit of questions there. But for the most part, any type of civil or linear based discipline will have one of those tools. And then you have to ask, are we doing plant? So in the world of IBI, predominantly no. I've only got small sectors or small areas that use plant. But if they're doing plant, do you have a process mechanical discipline lead? Do you have a piping discipline lead? Do you have a hydraulic lead? Do you have a corrosion lead, et cetera, et cetera, et cetera? So there could be some robust systems lead happens a lot, telecommunications. So you got to ask those questions. And when you start having those, landscape lead, you ask, what are the tools? And when you're doing project definition and deliverables, when we get to week 7, it could be, hey, here's all these tools. Next week is, hey, here's all the ways to collaborate. The week after is, here's all the BIM uses and potential tools we can go to. Week after that is, but wait, what do we have to actually deliver? And that'll be a critical thing because I want to empower you. If the deliverable is a DGN, and that's what some of the assignments talk about, a DGN deliverable, should we use Revit? Maybe. Or should we just use EcoSim? And that's a huge question. And I have those dialogues all the time. There's no right, there's no wrong. Well, the wrong is not meeting your deliverable requirements. There's no right, so there's no right as long as you have a workflow to achieve the deliverable. I'll be very clear on that. So note that when you do the assignments, and I hate saying there's no wrong, like you could be nuts in the assignment, but really the assignments are there to get you to think. The assignments are there to get you to say, Brent, pretend you're my project manager. Here's the solution I'm proposing to you. And it's awesome, right? And if you have something wrong in there, but it's thought out and it's cohesive, awesome. You're not going to get misgraded for an idea that may not wholly work. But I want you guys to just think about all of these things as they come together. So that was all just BIM authorship. So the BIM use of design authoring accommodated by one or many of those tools, building civil plans. Model review or design review, one of the most common ones we have. And I'm not going to dwell, surely I'm sure you've heard of a lot of these. Navisworks, one of the biggest. And the beauty of Navisworks, and something that I love, is it could take in maybe anything. I can't think of an example where I couldn't get something into Navisworks. Even SolidWorks, which is a very robust manufacturing tool. Autodesk Inventor as well, when you're just trying to do some real funky components. All this stuff goes into Navisworks quite nicely. Some come in with just geometry, some come in with geometry plus information, but for the purpose of design review, it is pretty slick. Oftentimes, I find many are not familiar with Bentley's version of Navisworks, which is Navigator. It's good. You know, I purposely used the same model as I dropped it in. Again, it understands authorship. Revit can go into it. DGNs can go into it. It uses, unfortunately, a customized file format called iModel. So the Bentley iModel or information model is their concept of bringing everything geometry plus data into one location. Unfortunately, it's not compatible with the IFC final file format. I've given them their criticism. It is what it is. But you've got the Autodesk, you've got the Bentley. What we find often on projects is sometimes we use them both. There's some slick abilities with Navigator, especially getting into iPads and mobile devices, that seems to work really, really good. Autodesk, still good, but you know, there's kind of benefits for both. IFC, once you have an IFC file and anything that's IFC compatible can very easily get into tools like Solibri, DDS-Pad, Tekla BIMsite, etc. And I saw some of you listing Solibri and BIMsite on. BIMX is another one that's ArchiCAD driven but IFC compatible. And XBIM is another one that's IFC. Something to note though, Solibri or IFC is very great for buildings, as buildings follow the IFC taxonomy. Plant and civil, no, but the iModel format brings plant and civil data into iModel, but really just on the Bentley side, unfortunately. And Navisworks brings everything in, but you have a lot of data degradation. So my message to you all as potential BIM coordinators is a bit of a mess. Sometimes, in my view, is all of these are available. All of these have free versions. And, you know, if you buy a seat of Revit, you get Navisworks. If you buy a seat of EcoSim, you get Navigator. So, you know, they're usually always at your disposal. 3D PDFs are very powerful. So again, same model, 3D PDF. Data passes through to an extent, and pretty good data too, from what I'm showing there. So, you know, think about it. Whatever's the right tool. 3D PDFs, I'll say I have definitely seen limitations. So of course I'm showing there a nice little tiny model. As model gets robust, putting a high-rise building or a heavy industrial plant into a 3D PDF doesn't normally work. And then I showed this, I think, in week 1, navigating your model via mobile apps, similar as you would a gaming console, accessing information, etc. Usually, I can think all of the apps I showed, if you just Google or search BIM on the App Store, there's a lot that come up. So other tools that, we're doing good on time, that I just want to put. So again, this isn't meant to be wholly robust, representing everything, but I just wanted to table things. Conceptual design is a very critical thing, okay? One of the myths, BIM hinders concept. So here showing SketchUp, just quickly SketchUp and InfraWorks. So the concept of the building concept or the civil concept to very easily manipulate and pull things together. Grasshopper, Rhino, Dynamo, Revit, pulling in algorithmic design and bringing those masses into either one of these other concept apps, or straight into the BIM authoring tools are very heavy as well. And I mentioned that when I went through the BIM myths, that the ability to harness quickly conceptual design tools is very critical. Comment here from Luciano. What do you think is better if you think the health of the model, having the model only in Tekla or Revit, for example, and try to work with all the tools from Revit, even if it's not sophisticated, or having the same model, Revit for architecture and export to Tekla for structural analysis, export to Navisworks for clashing. That is, I would say, the question of the century right now. So I struggle. I'm not in the camp of use Revit for everything just so it's in one spot. But in the same breath, you know, Revit is really good for buildings. So I've had projects, and I think in one of my case studies in week 11, I talk about the project where I think it was architecture was done in Revit, building mechanical was done in EcoSim, and I think structural, I think it was Revit too. So Tekla wasn't involved there, but you know, it just puts a challenge. And I would say it's not impossible as long as the BIM coordinator is involved to ensure interoperability and consistency. If I'm doing a building, I would prefer Arc, Struct, and MEP to either be all in EcoSim, all in Revit, all in ArchiCAD, etc., and then using analytical tools like, you know, Tekla to push into fabrication, or Robot, or whatever the required analytical tool would be, but at least the building model is wholeheartedly from a common point. In that same breath, I wouldn't want to jam Civil Implant into Revit, as I've stressed. So that would be my, you know, as a BIM coordinator, that's my recommendation is, you know, if things can all be together. These TTC projects we're on where they're requiring EcoSim, I've got my Revit users that are saying, oh, can't we do portions in Revit and make it go to EcoSim? And, you know, on the surface, sure, Revit, IFC, EcoSim, I have a workflow to get there. But if the client is going to be judging the model based on whether it's how native the components are, et cetera, that could be a challenge. So it might depend on deliverable. It might depend on workload. You might not have lead time for training. So if you only have an EcoSim user or you only have a Tekla user, you might be stuck. So yeah, and I guess as a BIM coordinators, I would say you've got to take the ideal with the business practical. And then we haven't touched project delivery yet down the road, but the scope, schedule, budget, right? So you've got to kind of take all of those and say, listen, I know that this solution is best. Think back to that cookbook, right? I know this recipe is best, but I know this recipe can work. And that's okay. But you have to stress then also, but hold on, that recipe you're proposing, that won't work. So if it doesn't work, be vocal. But if it could work, it could be okay. So conceptual, again, algorithmic design plays a large part, and we talked about that with the BIM myths in week 1, but there's no hindrance to that. So I don't want to dwell on that. Point clouds are huge, huge, huge. And, you know, oftentimes there's Leica CloudWorks, but Autodesk has their recap tool. I just here usually just comparing Autodesk and Bentley as the two largest. Not many know of Bentley Descartes. So a lot of people think, oh, if I have a point cloud, this is my only avenue. I got to get it here. Well, no, Bentley says you can get it here too. Similar tools, point cloud manipulation, rationalization, cleanup, and utilization for referencing. If you're doing a full scan to BIM versus just a scan for reference, then there's different mechanisms to achieve that. When I teach this, I also like making mention of CADWorks. So Intergraph's CADWorks will take a rationalized point cloud, pull it into their modeling, their piping modeling tool, and have it's kind of like a point cloud interpreter. So basically, if you pretended this was supposed to be a pipe, I would click on it. CADWorks would look and say, hey, that looks like a pipe. Tell me what type of pipe you want. And then it'll actually go and route it along the points that are making up what would appear to be a pipe. So very impressive. And they started that about 5 years ago, so it's only getting better and better by now. Schedule simulation. So when we talk about the BIM uses in week 6, part of the critical thing for project definition and deliverables is, if you've defined that we will do schedule simulation, what are you going to do? And if, let's say, I'm working on a DB project, design build, for the contractor, and I know the contractor will be using Synchro, will be using Power Project, or Vico, or something else, am I modeling in a compatible manner? Remember that example I used, whichever week it was, this component you see here. Am I modeling this as one big monster component that goes up the entire high-rise? Or am I modeling as it's meant to be built, as I understand it, which it can therefore be harnessed by the contractor for this specific BIM use? Very critical to think about that, and then ensure that, you know, we have that ability to speak. Now, if it's just a traditional design bid build, if you know it's going to go to a contractor for these things, you can try to plan for it accordingly. But if it's design build and the contractor wants that model and you're the BIM coordinator on the design side, take that model as it starts and get it to the contractor. Start to analyze and interpret what's being done, how's it being done, and is it successful to facilitate and achieve the BIM use. Don't wait to the end. Don't wait till the model's at 90% to find out there's a fundamental error that could have been fixed or set up back at 20%, for example. Fabrication, and this is where I use tools like Tekla, you know, to get to the 350 model. So this is going back to the LODs. The difference, and I think I alluded to that in week 2. Am I doing an LOD 300 or 350? And this is a great example of the difference between a 300 and 350, a design versus a fabrication model, and then how that then relates and becomes a 400 model. As a structural engineer, I would never model this. And we'll talk about that in the legal world. But oftentimes I want to make sure, oftentimes BIM coordinators don't understand why engineers or architects are just, no, we won't do that. So legal, we'll talk about that, but this is not what a structural design engineer will engineer. It just won't do that. They'll look at load analysis, but not they won't engineer the connection. I do my design model, it goes to the fabricator, they engineer and seal what you're seeing over here. So the challenge from the world of the contractor is, if we cannot get the shop drawing providers to give us fabrication models that they can then bring to 400, and they want to do 400, they're dependent on design models to further. We won't do that detail because we're not liable for that. But that doesn't break BIM. It just means the data lineage, if you will, has a potential hole. We're getting better at this. The supply chain is becoming, they're drinking the BIM Kool-Aid, if you will. So they're pulling together, and all of a sudden the flow of information is coming together. So like I showed a couple of weeks ago, or last week, I can't remember now, design models, fabrication model, construction model, again, if they're separate things, digital entities, if they're all together in one with different data layers on or off, etc., it's bringing that robust nature to me as a potential owner one day to say, okay, I need a certain level of development for my asset management. I may want to have a record of what's buried in the wall as per these connections, but I'll never see them again the rest of my life. And I can start to make intelligent decisions based on what's being modeled and why it's being modeled. Component management, so data management. If you've heard of any of these, Codebook, Rufus, FM Systems, there's so many out there. IBI has their own custom tool. I didn't want to put it on here, but it's called Inform by IBI Group. Ways of managing information and having connectivities or hooks into the BIM models. And they all do it in various ways. So Codebook is interesting. It's more healthcare focused, developing room data sheets. So it basically looks at a space, hooks only into Revit. So it looks at a Revit space. You define what should be in the space. And then once you have defined those 10 or 15 things, Codebook has a record of what those assets are. It looks into Revit, finds a family that accommodates the asset, puts the assets inside the space, lets me lay it out, and then does a validation of the stuff is there. Pretty cool. Similar concept with the Rufus. It takes, I think it's an IFC that goes Revit using the IFC engine into the Rufus and then analyzes spaces and what should be inside. And then visualization tools. So there's a plethora here. And I manage our Viz team inside IBI Group. 3D Studio Max with V-Ray rendering is their most common thing for images and animations. The Unreal and the Unity engine for going in, then they're using both because we're experimenting for going into virtual reality. And then looking at other tools that are surfacing in the market to accommodate augmented reality potential solutions. So it's never ending. The gaming industry, the beauty of Autodesk here is that Autodesk has design, AEC industry design, manufacturing industry, as well as the gaming industry and the movies. And a lot of the gaming and movie technology has infiltrated into the AEC industry to allow us to accommodate some pretty phenomenal stuff. So closing, just a teaser for next week. There's a couple things I wanted to show here. Ways to do workflows. And this is what you have to think of, that, you know, you can get information from one to the other. So a long time ago in Revit, Bentley added an add-on that allows you to publish an iModel and view it inside Bentley. It basically says anything you have Revit, we'll publish it, pull it into our collaboration systems Bentley, and expose it for visibility inside the Bentley world. And this, I made these slides in 2013, these ones. So this was a huge thing, starting to bridge that gap. So you ask, well, what if my architect is just Revit, but I'm in a major engineering firm that's all Bentley? It's fine. The architect, and I had several projects just like this. The architect, as long as they're publishing that iModel for me, I have their model as a backdrop, rich with information. Revit to AutoCAD or MicroStation, challenges there. So this is going from the Revit environment out to a DWG or a DGN environment. Oftentimes it's just geometry. So it's great, you can export. And if you have been in Revit, export to CAD, you can select your item, then you open up AutoCAD and you get your stuff in there and you can, you know, link it in your system. The challenge there is the intelligence gets lost. So these are, in Revit, it's very explicit, export to CAD. So you're losing BIM. Even though 3D graphics, you're just losing a lot of the intelligence. Not the same as the IFC export that's deliberately designed to maintain information. Bentley and AutoCAD into Revit. This is one I've done in the past. Revit, you can link models. Beautiful. So browse to your collaboration system. Notice I keep referencing collaboration system. It's all kind of prelude to next week. And I reference a model, and then I add what I need. So this here, it's showing there's a link. This here, the red, that's a piping model that's from Bentley. I think I made that with OpenPlant or PlantSpace. I can't remember. And then the rest is a Revit building. I can model around that Bentley model, make sure there's no interferences. So again, this would be an example where the pipers are all Bentley based. The specs are all in Bentley. Nothing is in Revit that team wants to use. I can still have it be intelligent. Then I can pull it all into Navisworks or Navigator if I wanted to do formal class detections and stuff. But in the world of Revit, at least I have the backdrop for me to model. So I'm not placing, I don't know, my door or I have enough clearance around my columns there in order to move to get to the bottom, to the stairs and everything. So these things are doable even if it involves a workflow in a system. Sorry, there's a question here. Is there any market? Is there in the market any tool that checks if your architectural model is following the code? Haha, yes. For example, checking handrails, distances from bathrooms. If not, can you create Dynamo that verifies and checks? I'm sure there's a possibility in Dynamo. So right now, today, no. Automated code checking is something that's, there's a committee in the Building Smart International group that's looking at how to facilitate this. And as part of IBI's technology team that I'm talking about, that I'm leading, we're looking at an automated bot, so a digital robot to do that. And one challenge, and it's an unfortunate challenge, is a lot of the building code is subjective, which kind of sucks. But I'll say there are clear items in the code that you need. Clearances, so barrier-free clearances around doors, minimum widths of doors, widths of hallway, dead-end corridor, etc. So I have a vision of making something where if I had this little bot popping up inside Revit telling you, hey, I'm modeling my corridor, and it pops up and says, ooh, you have a dead-end corridor. I add the door, it says, all right, now you're good. Or I had a door and it's too thin, it pops up and says this. So what I'd like to do is have a robot that actually scans the building code and the various codes, because there's differences in just Canada alone, national versus provincial codes. But I'd love it to scan the codes and portray the objective items, the stuff that I'm not going to dispute. And then either minimalistically, I send it an IFC file and it reviews it and gives me back a code review, or optimally is actually in there live. And there's other, if you Google, there's other outfits that are trying to dream these things up as well. So interoperability. I think if you read my introduction, I mentioned my career has been all about interoperability. I've always been on projects, or for the most part, my projects have involved applications scattered across, whether it's geographically or whether it's across platforms. So, most geometry can traverse the platforms, as I was just describing, but data doesn't always. So know that, and that's critical when you think of your BIM uses. If my BIM use is creating remember those three fundamental uses: design authorship, so drawings and schedules, design review, and visualization. If that's what I'm doing, data loss is maybe okay, because it's not going to compromise my visualization. So I can pull something together into Max, and we do this a lot, 3D Studio Max. Lose all my data, get my visualization. But if I'm going to feed an asset management system, I better be very careful how I'm bringing information together. Multi-platform projects require additional coordination. So I get this all the time with directors. Brent, how much time does the BIM lead need? And I say it's like a heartbeat. Spikes at the beginning, so give them a week at the beginning, a week at the end, maybe 2 hours a week, and a spike, so maybe a day at every deliverable. And they go, oh, okay, we can plan for that. And then I say, hold on, tell me about your project. Oh, we got someone in India, someone in London, someone in Toronto. One wants to use Revit, one wants to use EcoSim, and one is doing a Civil 3D. Then I say, yeah, let's rethink about that budget I just told you. So those dialogues are so important, okay? And I know this just from the history. I yelled at Brent, you blew the budget, and I explained the budget was blown because scope was not well defined, schedule was horrible, whatever it is. So those dialogues are very important. Understand coordination and learning curves need to be accounted for. And that's not all on the BIM coordinator, but, listen. So this goes back to the EIR and the capability assessment. Owner wants us to do something, fine. We've got to use these pieces of software, great. BIM assessment, so we all get it. Oh, you don't get it. IT assessment. Oh, you've never used this software before. You don't know how to install it. We need to train on it. Okay, and resources. Oh, you're all new hires. Oh, they're all juniors. Nobody knows how a building comes together. Nobody knows how sites work. Those are all flags. And you know what? If that's how the project's going to go, that's fine. But it can't be taken to approach versus projects where I've had some great ones where it's all senior designers. They've all been modeling for years. They know how to specify products, and these models are just things of beauty. And I say, oh, great. So keep that in mind. And each year, interoperability becomes more and more seamless. Okay? Always needs to be coordinated. And as you pointed out earlier, more and more people can start to access combined files, easier collaboration mechanisms. The cloud, when we talk about collaboration, my God, the preamble I'll give about the cloud versus like what we have now versus what I had just 2 years ago. It's unbelievable, okay? the progress that's been made. So I think I showed this, the vision, and I made this in 2010. We should, in the perfect world, be able to do this with no issue. And that goes back to your question, do it all in Revit or do it all in multiple. If the world was right, we're all using common data taxonomies, hence the ISO standards coming out more and more with how we BIM and why we BIM and what we BIM, so that if you had this situation, why shouldn't it work? From anywhere, any firm. And remember, the larger our projects are, think of Crossrail in London, multi-billion-dollar UK pounds, Eglinton Crosstown here in Toronto, Panama Canal widening, all these types of projects. Never will it be one firm. Therefore, never will it be one location. Never one local network. Never. Just not going to happen. You're lucky if all your structural is in Revit or all your building. Yeah, actually, if ArcStruct and MEP on an entire project are all in Revit, let alone just one discipline all in Revit, for example. So as BIM coordinators, this has to be in your head. And the approach I take is, this is what we do. And then I find out, oh, everybody's in Revit? Okay. Oh, you're all just in our Toronto office? Awesome, piece of cake. And that's, but I take the drastic first. In IBI, any project can be done from anywhere using any application. So what are you BIMing and why are you BIMing it? What do you have to deliverable? What do you have to deliver? Are there any client needs? And are we using any specific BIM uses? And now let's work down that solution. And this is what we want to get to, our goal. Plan the project, scope how it's done, understand the intricacies of software, okay? Don't understand how to, you're not going to be modeling everything. Let's just understand the intricacies. If you walk out of here, out of this course, and you go into a project, it's just a firm just doing Revit, great. All of a sudden, you're asked to do, you know, you're in an architectural firm, and I've seen this, you want to do the building design, oh, there's going to be some piping running through it. Stand back and say, oh, I remember that that Brent guy talking our ears off about this plant stuff. Just, if your takeaway is, there's something unique about this plant stuff, that's awesome. Because I'll tell you, a lot of my BIM coordinators in IBI, they might not have had the plant discussion. So when I talk to them about this, they don't know. And, you know, I wish they did. Just the fundamental knowledge that plant is something. Making all this stuff talk is something. There's something to be said about all of this. And if you have that knowledge, wrong browser, if you have that knowledge and you have that defined, when we get to this, we can start to look at the collaboration. We know the potential software. We've now defined the software. Now it's, where are we going to be sharing this work? And that is huge. I can't stress that enough, okay? If you're lucky enough to have a handful of projects housed in your single office, I'm happy for you. So where are we sharing? Where's the information going? And are we sharing live or are we sharing instances? Just what are we doing? So with that, that's everything I wanted to talk about. I do want to ask, open any comments or questions, but before, because I don't want us to time out here. If you haven't done the quiz, it's open for 10 more minutes. Open it up and do that quiz, please. The week 3 assignments, it's, again, it's an in-depth BIM execution plan review. So based on that initial matrix you put in the discussion, take your means, do the compare and contrast. I don't have anything that opens this week. So again, going into next week, the quiz will close shortly. You'll still be a week, so next week is the 5th. You'll still be a week, assignment 3 is due here, but assignment week 5 opens up. And so for my advice, it would be if you can knock off the week 3 assignment in the coming week, that would be advisable. For me, the week 5 assignment's awesome. It's about collaboration and starts to get you thinking, in my mind, like it's about, you know, for me, it's the first challenge of what I often give to my BIM coordinators. Hey, Brent, there's a new project. I assign a coordinator, and the first thing I say is, go find out what's going on, man. Find out what the needs are, and find out where we're sharing. And then is it just IBI, or does it include externals? All these questions dictate how we're going to share our project. And yeah, no, it'll be fun. I have a passion about the stuff this week and next week. So, questions or comments? Let me see if there's any new one posted here. What are good asset management building operations softwares that make good use of the model created for construction? Well, I would say informed by IBI Group, but maybe I'll show you guys that at one point. For me, so I've done a lot of exploration on Archidata, Ecodomus, FM Systems which is owned by Autodesk, Autodesk Building Ops, Archibus. I'm missing one. It's not in my head. A lot of them, so it's interesting, a lot of them, so the IBI system, we designed it specifically to say we need to harness OpenBIM, and I need to be able to have a hook between the modeled components and an asset record. So some systems are stronger with asset records and the interaction of what's happening with that asset over the life cycle. Some systems say, you modeled it, give me a 2D plan, and we'll put markers in plan. Our system, we kind of have the 2D base, plus we use the model as a contextual overview. So, and I like that at a conference last week. That's one of what an owner said. So someone from the federal government came up and said, as long as your BIM is giving you the context of the asset and the ability to connect it to different streams of data. And it was very compatible with my view of asset management. There's multiple streams of data, many of which are not in the BIM model, but the BIM lets you know where it is. So very quickly, if you look at the closest light near you, okay, if you have to change that light bulb, do you know what the light bulb is? So what do? Open up the light, take off the light bulb, look at it, maybe you bring it with you to Home Depot, etc. But if you just scanned the barcode or pointed your phone and you have augmented reality data telling you this is the light, this is the fixture, this is the light bulb, this is the last time it was replaced, this is where you purchased it, and this is what you paid. That would be amazing, I think, right? So that's the data. But what if you're not there and somebody texts you, hey, go get a light bulb for the light in conference room X? Okay. I'd love to be able to pull up the system and see the information. But where is conference room X? So I'd love to see the contextual relationship of that light bulb. Is it above the table? So might have to climb on the table to change it. Is the conference room a triple height space? And that light bulb is very high that I need a ladder or a scissor lift, right? All those types of questions. The model should allow me to prepare operational capacity expansion or maintenance type aspects without having to be there to do an initial assessment, go get stuff, come back, and just time wasting. That's a very long-winded answer because that's been my life on asset management for a while. So good question though. Any other comments or questions? If not, that's cool. Compliments to everybody who participated in the discussion board. Again, it's open until midnight. Okay. So actually, on a side note, if you notice, I did grade the yes or no's of all the previous weeks. So the grade profile actually looks really good now because there's a lot of participation. If you haven't, I'm not going to extend discussion boards every week. Just go and add to the discussion board if you haven't already. But there was really good participation this week. Week 5, I believe, will open in 5 minutes, if I remember correctly. So just a quick note that this will pop open. Its discussion board will open. And again, I'm asking list 3 ways to collaborate. So just getting you some initial ideas about, 5 cloud-based tools and 3 ways of creating BIMs. So just a couple things to think about when you post that board. One more question here. Oops, this webinar is funny. Construction management, project simulations, are they all the same? Yeah, you know, and it's funny, that's a challenge, because I'll air some of IBI's dirty laundry. We struggled in IBI group with a ridiculous plethora of tools. Aconex, Onware, StatsLog, Newforma, elements of ProjectWise, elements of Autodesk BIM 360, Unity by Union Square, Chapu in the Middle East. I can go on and on. So a lot of them have similar things. A lot of them have higher functionality. If you're looking for BIM integration, Aconex have IFC integration. Newforma has a Revit hook. Aconex has a Revit hook. I don't know. So I've said to my CEO, I sure would love to govern this. And the problem is settling on one. Simulation is a little different because it depends on what you're trying to simulate. So if you're looking at schedule simulation, a lot of those I showed, Synchro and I can't remember what the Synchro and the other two, Velo, those are all very comparable. Project management tools, my goodness, there's again a plethora of those. So part of my robotics team, we're looking at what's called a digital project management bot. So it's again a robot that will kind of connect you to various sources of information. So instead of saying, oh, is my project in Newforma, and then tomorrow my project is in Aconex, as opposed to what's my project, or just what do I have to do? And it kind of, we're looking at mechanisms to connect you to what you have to do that in turn stream you to your sources of data. So I don't know, that's like, again, in its infancy, but that's, I think, a big problem in today's world is the management software is all over the place. So from a BIM coordinator, what I try to say is, if we're able to focus on the ones that tie into BIM information, tie into the eye of BIM, so the information of building information modeling, without duplicating or with proper automated workflows, those for me are the ones that are a little more powerful. Okay. So if that's all the questions, again, yep, I just stress, do hit the open items. And if you have any questions, obviously email me. I get the email on my phone. I'll answer as quickly as I can. And with that, thank you. And I hope this was insightful. And again, I hope it wasn't too much information, but I really want to impart on you guys as much as I can from the years of insanity. So thank you. And this will be posted. The link to this, as the others, will be posted right here under the PowerPoint in about, well, later this evening. Well, thank you, everybody, and have a good evening and a good week. Talk to you next week.